Hi everyone! In this Mission to Mars video, we're going to be talking about the next step in developing a mission to Mars, and that's handling Mars samples. Joining us today to talk about how and why we do that is Aaron Yazzie, a mechanical engineer on the Mars Perseverance rover. Thanks for joining us today, Aaron, and welcome.
Thank you so much. I'm happy to be here.
My first question has to do with the samples that we'll be collecting on Mars. What types of samples are we collecting, and how will we safely store them?
Well, the Perseverance rover has a very cool sample collection system. When the rover is driven to an area that scientists decide have interesting rocks that they might want to sample, the rover is able to use a large and powerful coring drill that's at the end of the robotic arm. This coring drill is able to select from 3 different types of drill bits depending on what kind of sampling it wants to do. One of the types of drill bits that the rover is able to use will actually abrade away the top surfaces of rocks so that science instruments can closely study the newly exposed unweathered layers of that rock. Another type of bit allows the drill to extract cylindrical rock cores. These rock cores are actually about the size of a piece of chalk, maybe only a little bit wider. Once they're broken off, they actually are collected directly into this extremely clean sample tube. And each of those sample tubes fit nicely inside each of our drill bits. So now that we have our precious rock core inside of our sample tube, which is inside of our drill bit, we can move that sample tube into its storage location inside the rover. So the rover uses its arm to move the drill bit into its storage location. Then there's actually another robotic system inside the body of the rover. It has a little arm that can reach out and grab that tube from inside of the bit, pull it out, move it to a few different stations that are inside the rover to get a volume measurement, take some pictures of the rock core, and then seal it to protect the rock. And then we can store that tube into its own dedicated storage location inside the rover. And then we actually have one more type of drill bit that allows us, instead of grabbing a solid piece of rock core, we can get a tube full of loose rocky material. We call that regolith. It uses the same method as the rock core to pass the sample inside the rover, seal it, and store it.
Now, why do we need to collect samples to return to Earth if we've already sent rovers to Mars to study them?
All of our past rovers, all the way up to Perseverance, have had some advanced science instruments and tools on board that they use to study Mars's geology really up close. However, because of all the factors that make it hard to send something to Mars and operate things in that kind of harsh environment, we're limited to the kinds of science tools that we can send. By bringing samples from Mars back to Earth, we'll be able to study them better here and easier with the science tools we have on Earth.
So what sorts of things are we hoping to learn by collecting these samples?
Rocks hold a lot of information inside them. They've been around for a long, long time on Mars's surface, and they've seen so much of Mars's history. By studying these rock samples, we can learn things about its past climate and environment, its history of water, and help us understand how it developed from a new baby planet into what it looks like today. But perhaps the biggest question that we want to answer by looking into Mars's ancient past is to see if these rocks show that Mars at one point had ancient living life on its surface.
Thanks so much for joining us, Aaron. We really appreciate you taking the time to talk with us about handling Mars samples, the last step in developing a mission to Mars.
Thank you so much. I had so much fun working on this mission to do my part in collecting samples from Mars, and I look forward to all our future missions, which by the time all of you students can become scientists and engineers yourself, and you could be a part of this.
Now that you've heard why this is so important, you're ready to complete your mission. We hope you've enjoyed learning how to develop a mission to the Red Planet, and we'll see you on Mars.